Welcome back! Make sure to have your Maestro intro project open and your working directory set to your course folder. Before we start, let's right-click on the CDK2 prepared entry to exclude it from the workspace to make things a bit neater. Now, select CDK2 prepared ligand, and then Control-click to also select Ligand 3D Builder and Ligand 2D Sketcher. In this video, we're going to prepare these ligands for docking using a tool called LigPrep. If you remember, we previously added this to our Favorites toolbar. If for some reason it is not in your Favorites toolbar, go to Tasks, search for LigPrep, and click on LigPrep. LigPrep uses EPIC to generate possible tautomeric, protonation, and conformational states at a specific pH. To learn more about EPIC, see the paper in the bibliography for this section. LigPrep also allows you to desalt your ligand and to specify how you want to treat the chiralities of your ligand. If you have a racemic mixture, for example, you might want to allow all chiralities to be sampled. You can read ligand structures in from a file, but for today, we're going to use the 3 selected structures from the entry list or project table. It is important for you to make sure that the pH ranges in the panel agree with whatever experimental conditions you're aiming to replicate in your project. Since our inputs are all 3D structures, we're going to choose Determine Chiralities from 3D Structure in the Stereoisomers section. This will allow us to use the 3-dimensional structures that we already have to specify chiralities. If you're pulling in 2D structures, you may want to select Retain Specific Chiralities if they are already specified in the 2D structure, or you can generate all combinations. From here, make sure to change the name of the job to LigPrep_intro. If you do not change the job name and you come back to this work in 3 months, it will be difficult to tell what LigPrep_1 was. So we recommend changing the name to something that will help you remember. Click Run. This job will take a few moments. LigPrep should be applied to ligand structures before any modeling tasks are done with the ligands. Now that we have run our first job from an application panel in Maestro, we should go through how to use the job monitor. First, let's click Jobs and then Monitor to open the panel. This contains information about every job that you've run in this project, including its status, what input files were used, and where it is now. From the Monitor panel, you can also kill a job that you started accidentally, or look into why a job that you launched may have died. Also note the Postmortem button. If you have a job that keeps on failing and you're not sure why, the Postmortem button will generate a file with all of the information surrounding your job. This will help the Schrödinger scientific and technical support team get to the bottom of whatever the issue may be. We also include options to remove structures and directory names in case you would prefer to not share that information. Once the job is done, a banner will pop up at the top of the workspace that says your LigPrep job has been incorporated. Incorporated means that it is now added to your entry list. Click View in the project. You'll notice that there are 5 new entries in the entry list underneath the group. Right-click on the group header and choose Include. All entries in the group are now included in the workspace. Notice that you could scroll through the 2D overlay in the bottom left of the workspace. While we would like to compare the LigPrep outputs, these ligands are no longer perfectly aligned to each other. It will be easier to compare the states by aligning them first. Now, let's align these ligands by coming up to Tasks. Again, search for Align and choose Ligand Alignment. In general, it can be helpful to try several different ligand alignment methods. An alignment method which works well for one set of compounds may not work for all compound groups across different projects. When doing that, remember to uncheck Overwrite Existing Entries in the panel. For Align Ligand From, choose Workspace. For the reference, select User Specified. We are going to choose the top CDK2_prepared_ligand entry as the reference. We are then going to use the maximum common substructure to define the scaffold. Check Overwrite Existing Entries and click Run. Once the alignment is completed, you can close the Ligand Alignment panel. Notice that the purity nitrogen is not protonated in the top CDK2 prepared ligand entry, but is protonated in the second one. You'll see the same thing with the 2 Ligand 3D Builder entries as well. For each input structure, the outputs are ordered in the entry list by epic state penalty, which are energetic penalties associated with the various ionization and tautomeric states. To view those values, click the cog in the entry list, select Show Property, click Choose, type State, and select State Penalty. Click OK, and you will now see that a new column has been added to the entry list with the epic state penalties for each of the LigPrep outputs. You can see there is quite a large penalty for protonating the pyridine nitrogen, indicating that the deprotonated compound is more energetically favorable at our specified pH. We are still going to dock each of these compounds in Module 4B. Great job! See you soon!